Welcome to the GRE Test Prep Program, Ask the Professor, brought to you by TrboTest. And as you probably already know, I am Professor Konstantine Onapolous, and I am your instructor throughout this program. The first question on Ask the Professor says, for which of the following positive integers is the square of that integer divided by the cube root of the same integer equal to 9 times that integer? Quite a question, and of course it stumps a lot of students when they see this on the GRE, but it's actually very simple, and let's walk it through. The first thing we do, of course, is ascertain the given data. They want to know what the square of an integer is. That same integer has to be cubed, and it'll equal 9 times the integer. And which of the integers here did they give us to pick from, A through E? All right, so solving it, the first thing we do was when they say square of an integer, just write it down, x squared. It's very simple. Get rid of the words, get it into math form, and you'll understand it quickly. Cube of an integer, of course, again, right into a math term. We have the cube of integer, 3 radical x. Then it says 9 times the integer. Well, we already determined that the integer is x, so we'll make it 9x. That's 9 times. So far, it's much easier because we can see it. But let's go ahead and plug those in. We have here some question answers, and there's circles, so we know it's only one correct answer. Remember, if it has a square, it's 2 or more. If it has a circle around the answer, when you see it on the GRE, you immediately know it's only one. So here we use back solving because they want to know which one of these integers works. So we have to remember first, of course, an integer is a whole number. It's not a fraction. It's not a decimal. So we have 5 of them to pick from. We know one of them is correct. So if we look at these, we have to be able to satisfy all 3 factors. It has to be squared. It has to be cubed and equal 9 times the integer. So we have those 3 factors. So immediately we can look at A and C, 4 and 16, and we know they can't work. All right, the cube root of 4 and 16 creates a non-integer. We need the answer to be an integer. So we can throw out A and C right up the top. We eliminate those. So now we're left with B, D, and E. Of course, B, if we plug it in, B, when we square it, is 64. Okay, that worked. But when we take and divide it by 2, can we make it the same as 9 times 8? Remember, it has to be 9 times the integer has to equal what the square was. So no, of course not. That's 72 versus 64. It doesn't work. D says 27. Well, 27 squared works fine. We know that the cube works fine. We know that 9 times 27 gives us the same answer. So yes, D is correct. At this point, we could stop on the GRE. There's no reason to go on to E and waste time. But for our purposes here, let's go ahead and look at E as well. If we look at E, 125 squared gives us 15,626 over 5. Okay. Now we have to ask ourselves, can we multiply 125 by 9 and get 15,009 or 626 over 5? No. So the answer has to be D. Regardless of which way you come at this, D will be the only answer that works. The next question, of course, has a number line. It starts off with a 0. It has a series of hash marks. We have 1, 2, 3, 4, 5 hash marks. We have a 0 on one end. We have a 2 on the other. Of course, we have the square root radical, 3 radical p. And the question says, if the hash marks above are equally spaced, what is the value of p? Well, you can look at it and immediately realize, well, it doesn't fit integers. We can't do that. So we have to do something with it. So let's take the data we have. Right? The data we have is their hash marks are equally spaced. No problem. We know the number line starts at 0, ends at 2. It has 5 hash marks between. All right. Then it asks the hash mark in question, of course. We have that. So they want to know the value of p. Let's solve. If number 2 equals 5 hash marks from 0. Let's count them. 1, 2, 3, 4, 5 hash marks from 0. Okay, then put the 2 over the 5. It gives us an answer now. We can divide the 2 over 5 into hash marks, and we can figure out exactly what every hash mark means. So let's go ahead and do that. The first thing we do for each hash mark, we have a 0. We have a 2/5, 4/5, 6/5, 8/5, and 2. Of course, we know that 2 is 10/5. So that works out perfectly. Now, let's take and plug in the radical. We have the radical. We know the radical fell at 8/5 mark on the hash mark. So we know that P equals 8 over 5 cubed. So we can go ahead and figure out what the answer is, but we immediately should know the trap answer here is B, 8 over 5. 8 over 5 only defines where that's found on a line, not the definition of P, so don't fall for that. So let's go ahead and cube 8 over 5. 8 over 5 cubed is 512 over 125. So P has to equal 512, 125, which is D. D is the correct answer. So the next question says, which of the following is equal to 10 raised to the negative 8 times 25 raised to the 7th times 2 raised to the 16th divided by 20 raised to the 6th times 8 raised to the negative 1. There's a lot going on there. It seems very complicated, but if you've taken one of our GRE classes that's offered through TrboTest, you would know how to answer this very quickly. So let's look at it. The first thing we have is a question. Which of the following is equal to this fraction? All right, so if we solve it, we need to know this. Given the fact that 10 raised to the negative 8 is the same thing as 1 over 10 raised to the 8th, right? Remember how to convert the rules of exponents when you have a negative, all right? And we also know that 1 over 8 minus negative 1, which is on the bottom, is the same thing as 8 raised to 1. So once we know those two numbers, this number and this number, we can substitute those and convert the process. All right, so we have the 20 to the 6th, the 20 to the 6th, the 8 to the negative 1, we have the 10 to the 8. Everything is mathematically correct here. All right, so let's take it to the next step. Okay, here we have 10 raised to the negative 8 times 25 to the 7th times 2 to the 16th over 20 to the 6th times 8 to the negative 1, raised to the negative 1. So if we convert this 10 to the negative 8, which becomes 8 to the 1, we move it over here, we keep the other two numbers. So everything now is a positive exponent. On the bottom, remember that 8 to the negative 1 is the same thing as 10 raised to the 8th power, and then we have the 20 raised to the 6th. So we're simplifying. We're plugging these numbers in and simplifying. The next step is to convert that into prime numbers. Of course, we know that 25, prime of 25 is the same thing as the square root, which is 5 squared multiplied by the power of 7. Then we have 2 to the 16th because 2 is already a prime number. Then 8 we bring down to prime, which is 2 raised to 3 times 1. On the bottom, of course, we know that 10 is not a prime number, but 10 is made up of two prime numbers, 2 and 5. So we create that raised to the 8. 20, not a prime number again. So we make that 2 times 5, but 2 raised to 2 gives us 4 times 5 is 20 times the 6th power. The answer then, of course, continues because we do the math here. 5 to the 2nd raised to the 7th is 5 to the 14th, etc. And you can see that there. So last but not least, we take and work the final math on this. Of course, we have 5 to the 14th times 2 to the 16th times 2 to the 3rd. With exponents, remember, if they have the same base, in this case, the base is 2, we just add the exponents together. So 16 plus 3 is 19, which gives us 2 to the 19th. Same thing happens on the bottom. We have 2 2s. So we take the power of 8 and the power of 12, add them together. We have 2 to the 20th. We have 2 5s. We have 5 to the 8th and 5 to the 6th. Add them together gives us 14. So now, when we take and divide the bottom numbers into the top numbers, we immediately realize something is happening. It's only 1/2. All right, so how did we get there? We had the 5 and 14 and the 5 and 14, they cancel each other out. Then we had the 2 and the 2, 20 and 19, so we end up with 1/2.